Dear students, in this class we discuss new chapter, that is t-test, or it is also called as a small sample test. In last class we learned large sample test. So large sample test, so it is called as a large sample test because your number of samples are more than 30, at least 30 or more than 30. So we can write greater than or equal to 30 samples are taken. Minimum 30 samples or more than 30 samples are taken for studying the statistic. And when the sample size comes down less than 30 up to 29, so we may take one sample, we may take two samples. So here sample size is very small. Maximum sample size is 30. So we call it as a small sample test. So here up to 29 samples or less than 30 samples. So if it becomes 30 or more than 30, large sample. If sample size become 29 or less than 30, then it is a small sample test. So what is the difference here? So in large sample test, we don't count for the degrees of freedom here. Just we go on checking because all samples may be tested or may not be tested. But in small sample test, when samples in small sample test, as samples are less in numbers, we go on study for each sample here. For example, 10 patients are there, belongs to corona. So we can observe each of them, we can study each of the corona patient. When it comes to hundreds together corona patients, we can't check everybody. We may randomly select any patients and we can check that person. So here there is no degree of freedom here. We can check for any person. But in t-test, degrees of freedom will be always less than 1. How? So suppose 10 patients are there. Daily one patient I am going to check. So every day, 10 days I check 10 patients. So here up to 9 days I have an option of checking any of the other 9 patients. So first day out of 10 I can check any one patient. So I have 1 by 10 chances. So that probability of selecting any particular patient is 1 by 10. So I have 9 more options. When it comes to second day, so one patient I already tested, so he has gone, I left him. So I go to another 9 patients. So out of 9 again I can select any one patient. So like that up to 9th day, even on 9th day, out of 2 patients I can select one patient. I have an option, I have a degree of freedom for selecting any patient there. But on 10th day, no option at all. So whoever is left at the end, I have to test him. So in t-test, as a small sample size we take here, so we go for checking degrees of freedom. So what is the degrees of freedom that testing for that particular item or observation which is under our study. So here we check for degrees of freedom, and here degrees of freedom is always -1, n minus 1. If n is 29, then 29 minus 1 is equal to 28 degrees of freedom I have. If sample size is 10, minus 1 is equal to 9 degrees of freedom I have. So always we write in front of small sample test that n minus 1 degrees of, always n minus 1 degrees of freedom in front of t distribution. And in the t distribution, for what things we test here. So first we test for the significance of mean of a population using small sample. So t-test itself is a mean for small test. Small sample we take here, that is less than 29 observation. So using small sample, we test for the significance of mean, whether assumed mean for population is correct or not. Then second one, we use test the difference between the mean of two population using two small samples and here independent samples. So first, for single mean, that is single population's mean, single population, and second one, two population. So as in large sample test, we checked for test for population means, that is equality of populations of mean. Therefore, large sample. In a t-test, we check for significance difference between two populations, taking small samples, and here small samples are two different samples. So, for example, Prerna 1 college, Prerna 2 college. So, Prerna 1 college in a Hubli city, the performance, the average marks scored by the students in Prerna 1 college, we can compare with that of Prerna 2 college, taking small sample, less than, we select around less than 29 students, say example, 10 students we take, maybe those who scored highest marks in any particular test, we select 10 students from Prerna 1 college, and again we select 10 students from Prerna 2 college, those who score highest marks, and we test both the students here and we compare who is best, whether both are equally intelligent, or Prerna 1 college students are intelligent than Prerna 2, or Prerna 2 college students are intelligent than Prerna 1 college. And last one, test for the difference between the means of a population using paired observation. Paired observation means here only one single population we take. For example, we take few students and we check them. We conduct an exam and see their results. After seeing their result, their performance in the test, we give them training. And after training, we again conduct the test. And what score they get, how much marks they score in that test with compared to the test before training, we compare whether that is there any difference even before giving training and after giving training, we check here. So this test is also called as before and after test, because only one population, here no two population, we compare for before and after effect. So before tsunami, after tsunami, before yoga, after yoga. So persons, their health condition, their BP, their sugar level, various aspects earlier, when certain treatment is given to them. So it may be yoga therapy. If yoga is given, then after yoga, what is the condition of health of those particular patients? And if any medicine, new medicine is introduced, so before introducing that medicine, before applying that medicine, checking the health condition of the patients, and after applying that, after giving that medicine, then what is the result, whether they are improved or not. So like that here, for a single population, before and after doing some treatment, we check. So that is the difference between means of paired observation. So for these three things, we compare in t-test, this small sample test chapter. Now, what are the steps to calculate here? So first step as in the large sample test, we write a null hypothesis. Then we write alternative hypothesis depending on the question what they have asked. So as same as there again. And here no proportions, only mean of single population, mean of two independent population, and means of paired observation. Only these three we test here. And alternative hypothesis will be less than, more than, non-equal. Oh, those three aspects only here. Okay, and pair distribution, any changes or no changes. The treatment has not affected at all, not equal to. Treatment has reduced the number of deaths, greater than. So like that here, H1 will be written based on the what question they have asked. And next comes the formula. So formula here, as a small sample test here uses n degrees of freedom. So here the formula is small sample test, we indicate it by T test. The name of chapter itself, T test. You write T here, and T is equal to x bar minus mu divided by based on samples we calculate here. So you write standard deviation divided by root of n minus 1. So 1 degrees of freedom we take. So n minus 1 tends to T distribution. With n minus 1 degrees of freedom. So this is the formula for single population, first one. And next two populations. So there x bar 1 minus x bar 2 we take. So T test for two populations, x bar 1 minus x bar 2 divided by root of SC square, that is combined standard deviation of both the samples, into bracket 1 divided by n1 plus 1 divided by n2 tends to T with, as here we are taking two samples, so both the samples n1 plus n2 minus 2 degrees of freedom. So why 2 here? So for first sample n minus 1, and for second sample again n minus 1 degrees of freedom. So n1 minus 1 plus n2 minus 1. So n1 plus n2 minus 2 degrees of freedom is taken here. And third one, that is a paired deviation. So here we take the difference. So for difference we check here, that is before treatment and after treatment. So the formula here, T is equal to D bar divided by. So D bar means mean of the differences of both observation before and after, and D bar divided by standard deviation of the differences divided by root n minus 1 tends to T with n minus 1 degrees of freedom. So here we are checking for two different population, but same population where treatment is after giving the treatment we are checking again. So only one single population we are checking two different times. So n minus 1 only. Here two different population. So n1 plus n2 minus 2 degrees of freedom. So that is the difference between all these three tests and their formulas. And in the next class onwards, we start solving problems on these three concepts.